everyone. This is 12:30, so I'm going to start the lecture. Before I start the lecture, does any of you have any questions? Okay. So as most of you have received the email, masks are not mandated anymore, and I still highly encourage you wear them because sometimes your friends are, might have COVID, but they're symptomatic. So, we don't know. And also you can prevent like other things like cold, flu, and all that. So, but I'm not going to mandate that. I couldn't even mandate it before fully when it was mandated. So I still wear it because I just want to be safe. And I highly encourage you to wear it too. And if you're not wearing a mask, I expect you not to come to the class if you have any symptoms, like if you're coughing, if you're like sneezing, having sore throat, any symptoms that you have, even if allergies, I ask you not to come to the class, even if you're sure it's not COVID. Because when you cough next to a student, next to your classmate, they don't know it's only an allergy, and it may concern them and me, right? And your health and safety is my top priority. So please stay home. And you saw, I have attendance mandatory, but when you email me and say that you're not feeling well, I don't, mandate you come to the class, right? So as long as you just email me that you're not feeling well, you're welcome to just be home and watch the lecture online. Any questions about that? Okay. Now I'm going to start chapter 5. And if you have like some time at the end of the class, I solved some examples about atomic mass from last session. But first I want to progress with the lecture a little more. So chapter 5 is about molecules and compounds. And so far we studied elements mostly. And can anyone remind us how we can find a list of elements? If I ask you to name like 10 elements, I know that some of you, listen to me and then memorize the elements that I told you. But if you don't know all the elements, where would you refer to have the name of elements? Periodic table, right? You have like 2 nice periodic tables in the walls of this class. And also you have like several different versions in your book and also internet, right? So can anyone name elements in group 4? The ones that I asked you to remember? And you also have them here too, right? Remember class participation?
10 less. Is that what you're talking about? What you asked us to remember last?
Yes, yeah. And then can anyone just name group 4 elements from the beginning? Anyone? I mean, you all have that, right? Are you? Yes?
Carbon, silicon, germanium, tin, lead, and chromium. Is that what it is?
Yeah. Right? So remember, carbon, silicon, germanium, tin, lead. And this is like all you need to know. Now I'm going to ask you to remember some more elements, and these belong to group 5A. Okay? And as we progress with the lecture, you see if you know these elements, you can learn the materials much better and you will be faster in answering questions. So nitrogen, phosphorus, arsenic, antimony, bismuth. And it just kind of like went through all of them. So hopefully we can remember that. Especially nitrogen, phosphorus, arsenic. So try to remember them, especially nitrogen. We're going to deal with that a lot in this class. So remember, they belong to group 5A. Any questions? And again, I also always include this picture. I like it a lot because you can see metals versus non-metals versus metalloids. And when I ask you in the exam, which of the following is not a metal, you can answer the question better. But as I said, in your exam, you'll be having a black and white periodic table. So try to remember elements that are metalloid. Does that make sense? Okay. And again, these things you keep saying in your homeworks and quizzes, and you'll see that in exam 2. I asked you which of the following is not an alkali metal. And I include these slides several times, so in the exam you don't have the group names, you have like a periodic table like the one on the wall. And if you don't know group 1A elements are alkali metals, you most likely cannot answer that question in your exam. And questions in exam, they have like 4 points for each question. So if you don't know this, you may answer like 3 questions wrong. So make sure you know these group names. So if I say, is the following statement true or false? B is an alkaline earth metal. True or false? False, right? That is Be or Ba. B is boron, and it belongs to group 3A. Or if I say Br is an alkaline earth metal, Br. True or false? False, right? Because it's a halogen. It's in group 7A. But don't confuse that with Be, Ba, B. You see, there are like several elements. That's why I asked you to practice the periodic table, so you'll be comfortable with like metals, non-metals, and all that. So if I ask you which of the following is not a metal, and don't get confused when I say like we have non-metals, right? We have like metalloids, we have like metals, and sometimes I ask you which of the following is a non-metal, right? Or sometimes I ask you which of the following is not a metal. So when I ask you which of the following is not a metal, metalloids can also be an answer. But when I ask you which of the following is a non-metal, you should specifically name non-metals, not metalloids. Does that make sense? So just pay attention to the question of what it asks you. So if I ask you which of the following is not a metal, and I ask you like Be, Ba, B. B, right? So these two belong here, then there are like alkaline earth metals. So make sure to know these different groups well. And this chapter, we're going to talk about compounds, and if this slide that I included like for the past several sessions, if you learn them well, this chapter would be a little easier for you. So can anyone tell me what is a compound? Is air a compound?
Yes.
How many say that air is a compound? Okay, how many say air is not a compound? So can anyone, for the people who say air is a compound, can you give me an example or like a reason? Yes?
There's a combination of elements like oxygen, nitrogen, and other ones that I can't remember, but all of them, come together to
Okay. Yes, so air is primarily oxygen and nitrogen, right? So does this definition apply to air? That is a substance composed of 2 or more elements in fixed, definite proportions. Does this definition apply? So what is the, yes?
No, I'd probably say none, because I think depending on where you are, that air probably has different levels of oxygen and nitrogen, so I think the properties probably change.
Uh-huh. Yes. Yes.
Because air is a mixture of compounds, because O is often O2.
Exactly. So you see, you're right in the sense that we have like oxygen and nitrogen in air. But something that you should consider is that we have like O2 molecules, and today we're going to talk about more about this. And we have nitrogen molecules, right? So if you had, for instance, like NO2, which by the way, we have like these compounds in air, especially when we have like pollution, we have like NOx, NO2, we have like sometimes sulfur compounds like SO2, SO that we don't want to have them, or like carbon dioxide and so forth. But if air was like NO2, that we had like 2 or more elements in fixed definite proportions, yes, that would be a compound. But that is not the case for air. In air, we have like N2 and O2 molecules mixed together, okay? And as your friend mentioned, depending on where we are, usually it's like most of the air is like nitrogen. I think the proportion was like 79-21, 79% nitrogen, 21 oxygen. But most of it is nitrogen, and then we have oxygen. But if you're like next to a factory that they generate carbon dioxide into the air, the oxygen level would be less, and nitrogen of course, and you have like more carbon dioxide. Or imagine if this class is empty, there is no student, the level of oxygen would be more. But if we have like 200 students in this class, and then each room has like a limitation of how many people can be in the room, because there would be lots of carbon dioxide, right? So as your friend mentioned, depending on where we are, this mixture can have like more oxygen or more nitrogen or like other compounds in it. So for that matter, air, and this is kind of like the other part that we had like here, mixtures, remember? Mixtures, and then you had like homogeneous and heterogeneous. So remember, air is a mixture. So it's not a compound. In order for us to have a compound, we should have 2 or more elements attached to each other in fixed, definite proportions. So this is really important here to remember. So that's why mixture of O2 and N2 is not a compound, but NO2, I guess I write it here, NO2 is a compound, because for each nitrogen atom, and then here when I don't write, the number here is like implied 1. For 1 nitrogen atom, I have 2 oxygen atoms. Any questions about compounds? Okay. Now, we want to talk more about compounds. And as I just mentioned, compounds show or display a constant composition. What does that mean is that if you have, and your book has like these pictures, so I just like include them here. Hopefully it's clear what it's talking about. So in the picture on the left, you have a balloon that you have like hydrogen and oxygen gases in them. So basically you have like H2 and O2 molecules. And I guess your book also could have like example of air that has like the same example that I gave in the previous slide, that you have like O2 molecules and N2 molecules, right? So that is a mixture, because you have like 2 gases that you combine them in a fixed, you have like 2 compounds that you just like mix them together, okay? But on the right, it had like the balloon and fill that with water, right? And if you fill that balloon with water, if you have water inside of it, you may remember, I just mentioned that briefly before, that the formula of water is H2O. It means that for 2 hydrogen atoms, you have 1 oxygen atom. And this proportion is fixed. So you cannot have like HO and call that water, or H3O. So for that matter, we have law of constant composition. And I keep asking you in your homeworks, quizzes, exams, and all that, law of constant composition, which states all samples of a given compound have the same proportions of their constituent element. Or I give you some options and say which of the following is consistent with the law of constant composition. We can have a compound with formulas of like HO, H2O, H3O. So this is not consistent. Or I say like in CO2, in carbon dioxide, and we learn how to name compounds like in the next lecture. So I say for like 1 carbon atom, and then again when I don't write the number here, it's just 1. But it exists. Sometimes the students think that number is 0. If it was 0, you wouldn't be having any carbon, right? You have only 1, but we can just like not write 1. When I don't write anything here, it means that it is 1. So for 1 carbon atom, I have 2 oxygen atoms. And if I have anything else, that wouldn't be carbon dioxide anymore. It would be some other compound. Does that make sense? Any questions? Okay, now we want to learn how to write, chemical formulas. And chemical formulas are a way for us to, with chemical formulas, we can represent molecules or compounds in general. So a chemical formula indicates the elements present in the compound, like H2O that we had an example, right? We have hydrogen and oxygen atoms, or like hydrogen and oxygen elements in the compound. So it gives us the name of the elements and also the number of atoms of each element. So elements present in the compound and the relative number of atoms of each element. So H2O tells you that we have hydrogen, we have oxygen. Also, the subscript indicates the number of each atom. So here, since we didn't write anything, it indicates 1. So for 1 oxygen atom, you have 2 hydrogen atoms. Is that clear? Any questions? So can anyone tell me what elements do I have in this compound and what is the number of atoms for each element? Yes?
You have 1 carbon element and 2 oxygen elements.
Exactly. So you have like carbon and oxygen elements, and for 1 carbon for 1 carbon atom, you have 2 oxygen atoms. So what about, and as I said, I'm going to post this, so don't worry about if you're like, didn't write this. C6H12O6. This is glucose. This is sugar, basically. So what are the elements here and number of them? Yes, carbon, hydrogen, oxygen. And what is the number of elements? Or like number of each atom in this compound?
6 carbon, 12 oxygen, or 12 hydrogen, 6 oxygen.
Right. What about this compound? What elements you have here? Carbon, hydrogen. How many of each? 6 carbons, 12 hydrogens. Are we comfortable with these now? Good. So now, what about this? MgCl2. What elements do we have? Chlorine, right? How many of them? Right? So now these things seem easy, but when we talk about atomic charges and all that, students tend to confuse them with each other. So make sure to practice this so you don't get confused. So for 1 magnesium atom, we have 2 chlorine atoms. Okay? Now let's do the reverse. So I was giving you the formula, I was asking what elements I have, what are the number of atoms. Now it's the reverse. So I tell you in the homework assignment next week that write a chemical formula for each compound. The compound containing 2 aluminum atoms to every 3 oxygen atoms. So what is the first thing that you do when you have like this question? What's that? Yes. And if you study the things that I told you, probably now you know aluminum well, because suppose it was in group 3A, so now you know what is the chemical symbol for that, or atomic symbol, and then the same for oxygen. I mean, oxygen we're gonna talk about next class. But regardless, you can go to the periodic table and then look up these elements, right? So what is the chemical or atomic symbol for aluminum? Al, right? So if you write Au, would be gold. If you write Ag, would be silver. And I give you these in the exam as wrong answers. Or if I just write A, that would be false too. So make sure that you're comfortable with the periodic table and know how to look up this information. What about oxygen? What is the atomic symbol for oxygen? Right? Again, if you write like OS or like OG, it would be like different elements. So make sure you know that. So now we want to have like 2 aluminum atoms to every 3 oxygen atoms. So I give you this in the exam and I say which one of the following is correct. And then I give you a bunch of these. So how would I write this? So you have like aluminum and oxygen. So what should be the subscript for aluminum? 2, right? What about oxygen? Right? Because you say like 3 oxygen atoms. So in the exam, it would be like this, Al2O3, not the other ones. Does that make sense? What about the next one? Let me write it with red. So 3 oxygen atoms to every sulfur atom. How would you write this one? So this is kind of like, I'm going to just write this momentarily, that we agree to kind of like write S first, but technically if you just write oxygen first too, that is correct too. So for every sulfur atom, it means like 1 sulfur, you have like 3 oxygen. So you write SO3, and I'm going to add this here, that it is basically your table 5.1, order of listing non-metal elements in a chemical formula. So you have like C, P, N, H, S, I, B, R, C, L, O, F. And then your book says elements on the left are generally listed before elements on the right. So that's why you write CO2, not O2C, or like SO3 instead of O3S. So technically it's correct, and I'm not going to give you both in the exam. But since scientists want to be consistent and then have like the same formulas, this is just what they agreed on. That first we write carbon, a number of atoms, then phosphorus, nitrogen, hydrogen, sulfur, iodine, and so till the rest. Does that make sense? So for that matter, we write like SO3, not O3S. It's just like convention. So like we agreed to write this like that. Any questions? What about the C part? The compound containing 4 chlorine atoms to every carbon atom. So which one do we write first? carbon, right? And then when it says for every carbon atom, it means that for one carbon, we have 4 chlorine atoms, right? So we write C1, Cl4, and then we can just skip writing 1. So we write CCl4. Are we comfortable with writing this? Good. Questions? Okay. Mouse back here. So this session, I'm just introducing so many different definitions and concepts. So it's kind of like the language of what we are going to study. So make sure to go through them and then know them well. Now we want to talk about polyatomic ions. So just from the name, can anyone tell me what do you think polyatomic ion mean? Yes. So the polyatomic is like many atoms. An ion is a particle or something that has a charge, right? So polyatomic ions are ions that they have like overall charge. An ion composed of a group of atoms with an overall charge. And you have like this table in your book that I'm not going to ask you to remember the names, so I'm going to give that in your exam. But I highly encourage you to go through it and kind of like learn the names, because we're going to talk about naming ionic compounds next class. And if you know these names, kind of like, when you solve more examples in exams, you'll be less confused about like nitrate, nitrite, or like nitride. So make sure to practice this. And then we have like acetate, carbonate, nitrate, nitrite, and ammonium. So these are like, all of them we're going to use, and I'm going to give you in the exam. But some of them we use like, more. So sulfate, sulfite, peroxide. So if I ask you, if we consider acetate, what are the elements in acetate? Carbon, hydrogen, what else? Oxygen. How many oxygen atoms I have in one acetate? Right? How many hydrogens? How many carbon? What is my overall charge? What is it? Can anyone guess what is the overall charge of this polyatomic ion? Yes?
-1.
Exactly, it's not -1. So don't get confused. You can just like write -1 or 1 minus, those are the same. But don't get confused that there are like multiple atoms. All of them together have charge of -1. So we have C2H3O2. When we have like minus here, it means that the whole unit, all the atoms have charge of -1. Okay? So let's do sulfite, SO3, 2 minus. What elements we have? Yes. So how many sulfur atoms I have? How many oxygen? What is my overall charge? 2 minus or -2. Those are like the same, whichever you're more comfortable to write. Are we comfortable now with like polyatomic ions? So there are like ions that they have like several number of atoms, 2 or more. And sometimes you have only 2, like CN, cyanide, or like OH minus, where is it? Hydroxide. You have like 2 atoms with overall charge. So necessarily, or sometimes like hydrogen phosphate, you have like 6 atoms. And also you should, now that I write these numbers here, you should also be able to add them. If I ask you, in one chloride, how many atoms do I have? How many in one chloride? So this is chloride, right? Y4. So I have like, I write that here. Right, ClO2 minus. So you have like 1 here, 2 here, right? Is that clear to everyone? Any questions? Okay. If you're fine with that, now I want to talk about types of chemical formulas. So we just talked about like molecular formulas in the previous slide, that it shows you how many elements we have, what type of elements we have, and then the number of atoms of each element. So even like when we deal with chemical formulas, one type can be empirical formula. An empirical formula gives you the smallest ratio. And when we talk about like smallest or like simplest ratio, we mean like whole number. And that is the case for all chemical formulas, whether like empirical or molecular formula. I don't write, like when I write H2O, I don't write it as like HO half. I write whole numbers. So I don't deal with ratios, I don't deal with like decimal points, right? So when you report a chemical formula, make sure that you're dealing with whole numbers. 1, 2, 3, 4, 5, so on. Does that make sense? So we don't have like 3.5 or 3.4, okay? So we don't write it as this. Although mathematically it's correct, but we don't do that. So if we have like simplest whole number ratio of atoms of each element in a compound, we call that empirical formula. For instance, remember the glucose formula that I told you before, C6H12O6. You see that you can divide all the numbers by 6, right? So you can write this as like C1H2O1. What I did, I divided all these numbers by 6, right? So mathematically, these two are the same. For one carbon atom, I have 2 hydrogen atoms and 1 oxygen atom. So we call this one empirical formula because that is the simplest whole number ratio of atoms. But this one, which is molecular formula, gives me the actual number of atoms. So we don't simplify them. This is like the actual. So actual number of atoms of each element in a compound is like molecular formula. Is that clear? Any questions? So if I ask you, and I was giving that nonstop in the exam last semester, C6H12, is this empirical or molecular formula? Molecular, right? So what is the empirical formula? CH2, right? You divide both of these numbers by 6. And write this version. So this is empirical, this is molecular. Any questions about this? Are we clear? What is this? Oh, okay. So I'm gonna go back to my slide. And again, if you didn't write this, I'm going to post everything, so don't worry about that. Now we want to talk about the structural formula. So as the name suggests, a structural formula basically shows the structure of the atoms and how, they bond with each other and how, they're located compared to one another. So specifically, we use lines to represent chemical bonds, and structural formulas show how atoms in a molecule are connected to each other. And I'm going to show you some examples. But basically in the structural formulas, if I just tell you H2O, you know that you have like 2 hydrogen atoms for 1 oxygen atom, but you have no idea how they are connected to each other, right? But if I show you the structural formula, which is H2O, you see that, okay, there is one bond between oxygen and hydrogen. So we use like lines as kind of like chemical bonds to represent how these atoms are connected to each other. Any questions? Okay, the other types of chemical formulas are molecular models. And molecular models are really similar to the structural formulas, but they show a 3D, three-dimensional representation of the molecule. So that is the difference. And basically, there are a way to represent molecules. And then we have like two different, or we study at least in this class, two different types of the molecular models. One of them is like, so I just wrote the ball and stick model. I kind of wrote the definition, but forgot to write what they represent. And here is the space filling model. So in ball and stick model, you have like atoms, and all you represent atoms as balls, and then the bonds as sticks, basically. And then for a space filling model, you have like atoms and represent them like as spheres, and they overlap with each other. So big molecular models, as we mentioned here, ball and stick model, the other is like space filling. Basically here you have like ball and stick, again, you have like the elements as balls and kind of like the bonds between them as sticks. So we call them ball and stick model. And then the space filling, you have like the elements as like spheres, and then they overlap each other. Does that make sense? So again, these are like just definitions and things that you should just remember. And if I give you a compound like this or that or each of these, you should be able to identify what they are. Like here that we have like CH4, this is a molecular formula. And it also can be empirical formula, right? Because you cannot simplify CH4 more, right? So it can be empirical formula, it is molecular formula, and this is its structural formula, that it shows you, we use lines to show the chemical bonds. And this is like ball and stick model, basically here, and then space filling model, that you have like elements as spheres. And I'm going to give you lots of true and false questions. Is the following statement true or false? In ball and stick model, we represent atoms as spheres that overlap with each other. False, right? So as long as you know the definitions, the homework problems should be fairly. Any questions about these before I go to the next slide? Yes?
So when we write down our formula, we want to write it in the most simplified way possible. We want to keep it in molecular formula.
So we deal most of the time in this class, we deal with molecular formulas, unless I ask you what is the empirical formula for this compound. So we deal with molecular formula, and we are interested to know actually how many atoms are present in the compound. Like glucose is like C6H12O6. So we want to know how many atoms we are. But, there are ways to calculate and then find out molecular formulas based on empirical formula, and we're going to talk about those. But right now we deal with molecular formulas. Great question. Any other questions? Good. Easy. Okay, if no question, I just went back to this slide, and the reason is that now I'm going to kind of upgrade it to the next slide and add things to it. So remember, pure substances are elements, compounds, and now we want to talk about these in more detail. You have definition here as well. So if you have forget the definition, just go back to the cell, which is this slide. So pure substances are categorized to elements and compounds. And now we're going to talk about atomic elements and molecular elements. And also, compounds are categorized to molecular compounds and ionic compounds. So each of them, I included basically your textbook. in the next slides, but just by looking at this and also the examples that you see. Can anyone tell me what is an atomic element? Or give an example. Is O2 an atomic element? No, right? So atomic element is just basically one single element by itself, like neon. All your noble gases, helium, neon, argon, krypton, xenon, or like radon as well. So all of these are just like one atom. You don't have He2 or like Ne2. And as we progress with the lecture, I tell you why that is. But right now, we just study these that, okay, noble gases are just like elements by themselves. Or like when you have like metals, right, in the periodic table, most of the time, if you just have them as themselves, not in compounds, they're just like atomic elements most of the time. Not always, but most of the time. And molecular elements, first of all, is like CO2 a molecular element? Is CO2 an element? No, yeah. So CO2 is a compound. So don't get confused. And I'm going to ask you, as I said, like true or false questions. So sometimes you see molecular elements and you tend to think that maybe H2O, CO2, CO, maybe there are like molecular elements. So when we're talking about elements, we should only have one element. So molecular elements, most of the time, there are like two elements attached to each other, like O2, right? Like N2, like H2. Each of them by themselves, not the combination of them. If we mix them together, it would be a mixture, right? But each of these individually are molecular elements. Does that make sense? And now compounds. So can anyone tell me what was the definition of a compound?
Two or more elements formed together.
Yes.
Indefinite sizes or something like that.
Exactly, in fixed, definite proportions, right? So remember that definition, and if I gave you something that wasn't consistent with that definition, you know it's not a compound. But compounds itself, now we know the definition, right? And also you can always reach out to me, as I said like several times, if you have any questions about any of the topics that we're talking about, don't feel ashamed or like frightened, I guess, to reach out to me. Even if you don't know any of these, I just explained everything to you. So just reach out to me. Anyway, so compounds can be molecular and ionic. So molecular compounds are like two or more nonmetals attached to each other, like H2O, like CO2, like CO, like C2H4, like C6H12O6. All of them are nonmetals, as you see. And ionic compounds are like cations plus anions. And 99% of the time, they would be metals plus nonmetals. But not always. We have like one exception. But you should like know that the more correct definition of ionic compounds are like cations that form bonds, ionic bonds, as we're going to talk about in the next class. We have cations form bonds, ionic bonds with anions, okay? So now kind of like NaCl, table salt, or like MgBr2, or like CaI2, okay? So kind of like some examples. And these are like for these molecular, these are for this ionic. And I want to go briefly to the definition. So these ones I just borrowed from your book. like stole from your book, that atomic elements have single atoms as their basic units. Most elements fall into this category, like helium, copper, and mercury. Okay? And molecular element. Molecular elements do not normally exist in nature with single atoms as their basic units. Like, most of the time we have diatomic molecules, and di here it means two. So we have like two atoms in the molecule, and kind of like H2, O2, Cl2, and so on and so forth. Okay? So this is kind of like basically the text of what I just told you. And we have molecular compounds that they are composed of two or more nonmetals, such as CO2, such as C3H6O. And you can have like multiple elements, not only two, right? Or like C6H12O6. Okay? And finally, we have the ionic compounds that they compose of one or more cations paired with one or more anions. In almost all the examples and everything that we study in this class, there would be one cation with one anion. But it can be like one or more cations paired with one or more anions. So if you see this in the true or false questions, don't feel that it should be wrong. Okay, this is the general definition. And most of the time, as I mentioned, ionic compounds would be metals plus nonmetals, but not always. Because if you go to the table of polyatomic ions that I included before, we have like NH4 plus ammonium that is a cation, but it's not a metal. Okay? So also take note of that. And you have like NaCl as an example. And I asked you guys to go through this slide and also all other slides and study them well, so you can answer all the homework questions correctly. So one of my students in my other class, they recommended that I use like QR codes. So I implemented that here. So hopefully your attendance would be like faster, but I included the link as well in case your phone like mine doesn't implement that or doesn't have QR code reader. So remember, homework 7 is due tonight. So, plan accordingly. If you have work till like 10 p.m., just like take the homework sooner, so you don't miss the credits for that.